My name is Eric Liefeld, and I'm the current president of Mesilla Valley Preservation. We're a small nonprofit dedicated to preserving the architectural legacy of the Mesilla Valley. Because so many of our buildings here are built of adobe, so many of our historical buildings, adobe is one of our key focuses. We care a lot about adobe technology, and we care about the things that affect adobe buildings. This is a building built of adobe, built of mud bricks, probably about 120 to 150 years old. What we're looking at here is some considerable structural damage that's happening to this building. This is actually something known as salt attack. And what we'll be doing today is taking a walking tour around the town of Mesilla, where we are currently, to show you examples of salt attack in its various forms. In other videos in this series, we'll show you how to actually measure salt attack and how to go about remediating salt attack damage. So looking at this wall, we can see that a lot of things have started to fall apart. We can see that down at the bottom we have this powdered area. This is actually really a hallmark of salt attack, wherever you see this very, very fine powder. This is regular hard adobe brick that has been essentially converted into a very fine powder. You can actually see that there are insects. Black widows tend to like to live in this kind of habitat. And we've got some antlions that have actually taken up living inside this powder. You can see that plaster has literally come off the wall in chunks. You can see layers of plaster that have worn away. You can see that I can actually remove bits of the aggregate in the plaster with my bare hand. And here you can see the various layers of plaster and paint as people have tried to combat this problem over time. Salt attack is actually a natural process. What we have is water rising by capillary action in the adobe wall. So water is rising in the very fine microscopic pores of the adobe into the base of the adobe wall. As the water rises in the wall, it carries with it a lot of dissolved salts because we have heavily alkaline soils here in the Mesilla Valley. As that water evaporates from the face of the wall, it leaves the salts behind. The salts literally crystallize. Sometimes those salts crystallize on the surface of the wall in a process called efflorescence. Sometimes, however, those salts crystallize in the very microscopic pores of the adobe itself. That's a process called subfluorescence. For a while it's fine, but as those crystals grow, they literally exert enormous crystallization pressures on the pores of the wall. The pressures can be up to over 8,000 pounds per square inch, which is literally over 4 tons per square inch. The salt crystals themselves explode the lattice of the adobe, and that's what results in these very, very fine particles here. This may look like a cosmetic problem, and yeah, there's a lot of cosmetics involved here, but the point is that this is actually a very serious structural problem. Adobe walls have considerable mass to them, and they're highly dependent on having enough width to support the mass of the wall. In this case, as you can see, we're losing lots of wall width. I can literally insert my hand the full depth here. As we remove width from the wall becomes destabilized. That can cause us ultimately to lose the wall of the building and the building overall. And here you can see how various parts of the plaster have just literally buckled out as the weight of the building starts to compress the compromised wall bases. So this is a pretty serious problem. We'll now be walking around Mesilla and showing you other examples to help recognize when salt attack appears. So now we're at the Blas Duran House here in Mesilla, New Mexico. We think this building dates from the late 1860s, early 1870s. What we see here is another great example of salt attack. This is an adobe building with some fairly massive adobe walls. We can see how over time people have been trying to deal with this problem. They've added a concrete collar, which I've got my hand on here. Locally that's called a contrapared, or against the wall literally in Spanish. And you can see numerous layers of plaster, stucco, paints, elastomeric coatings, and you can see that all of it is failing in the face of salt attack. You can see that all these layers are literally just coming apart and peeling off. The elastomeric layers, the paints, the latex paints and what have you, literally just bubble as the aggregate, as the material behind them is destroyed by salts. So this is a good indicator that we have a salt problem. This is different from the last one we looked at in that we don't see a lot of powdering adobe present. But based on what we see here, we can surmise that we've got a salt attack problem, and this is, we've got damage happening somewhere. Unfortunately, as people try to seal up the outside of the wall, what we end up doing very often is driving the salts inside, so we end up having salt attack on interior surfaces, which is not desirable. So this is another great example of the ongoing involvement of salts in a building in Mesilla. Here we can see that they've done the right thing. They've held the concrete sidewalk away from the building, giving the salts an area to, or the moisture an area to escape. Unfortunately, there's been a lot of accumulated salts in the building. We can see how there's been a lime plaster layer that was added at one point, which is a good thing to do. Unfortunately, later on, they added an elastomeric layer, or multiple elastomeric layers, and you can see this rather rubbery looking surface that is basically covering up the coved adobe that's behind that surface. The wall now is essentially falling apart behind the surface of the wall. So now we stand the risk of losing load-bearing structure, which is absolutely our worst case scenario. We'd much rather have that moisture escaping to the surface of the wall so that our salts are deposited in the outer layers of the wall. So unfortunately, people have added a rubbery elastomeric coating to the wall. So now we're losing actual load-bearing structure in the wall instead of the outer surface. So this is the opposite of what we'd like to happen. So this is another great example of salt attack. Normally we would see coving from salt attack taking place just above ground level, where the moisture evaporates from the surface of the wall. In this case, we see the salt attack happening very high up on this wall, literally 2 feet up on this wall. Why? Because somebody has come along and tried to repair the damage. They've done this by placing a large concrete patch in here with Portland cement. Portland cement is less permeable than the unstabilized adobe wall, so the moisture literally climbs right over it. So all that's been accomplished here by putting this large concrete patch in is that the moisture has climbed above it, the salts are being left behind, and the salt damage is now happening above the concrete patch. And so you can see the typical cove here. You can see the very fine powder that's a result of the salt attack. And you can see the grasses and straw and other components of the adobe being exposed as the salts literally destroy the adobe infrastructure around it. And unfortunately, this is just an exposed adobe wall. Part of this wall has literally already collapsed because of this problem. Because again, we're losing width of the wall at the base. I can put my hand, a good foot into the base of the wall. As the wall base becomes smaller and smaller, the stability of the wall is undermined and ultimately collapse is the result. So we're here at the historic Provencio House in Mesilla. This is literally one of the oldest houses here in Mesilla, built along the Acequia, we think in the early 1850s. So this is a great example of how people have tried to cope with salt attack over the years. In this case, as you can see from the building, people have added bricks, they've added all kinds of things to try to patch the wall. Those bricks are now literally sitting free as the adobe from around them has been eroded by salts. If this continues, the wall can be undermined. We can literally suffer an entire wall collapse, as has already happened to this building east of us. So we've looked at a bunch of examples of salt attack. We've looked at some attempts at dealing with salt attack over the years. Now we wanted to finish up the video by looking at a really nice example of what we think is the state of the art as far as dealing with this particular problem. This was a very seriously salt-affected wall a couple of years ago. A local contractor has done repair of the adobe structure, and they've done a number of things that we think are beneficial to helping this building deal with salts over time. For one thing, you can see that the concrete has been held back from the wall. They've actually cut the sidewalk so that the concrete is not driving moisture to the adobe wall. The wall has been reconstructed, as I said, with adobe. It's been plastered using a lime plaster, which allows the evaporation to take place at the surface of the wall, unlike the elastomeric plasters that we looked at that actually drive the moisture back into the wall. This element down here, where we've seen concrete collars before, this is actually an adobe collar, and it functions entirely differently. It actually acts as a sacrificial element for the salts. So if we start taking salt damage now, that's very likely to take place here outside the load-bearing structure of the wall. So this structure now, instead of being a problem, actually provides a benefit in that it's a sacrificial element for the wall, takes damage so that the load-bearing structure of the wall stays safe. So again, we think this represents the state of the art. We're actively experimenting with different approaches, but this has allowed us to migrate salts out of the structure, which we think can set the clock back for the building over time. So in this video, we've looked at a number of salt attack examples. We've looked at a number of efforts to deal with those, with that damage over time, some of which have not been so successful. We've looked at finally what we think represents the state of the art in being able to migrate salts out of load-bearing structure using permeable lime plasters and sacrificial elements. We'd encourage you to look at the rest of the videos in this series, which have been supported by the National Center for Preservation Technology and Training, and encourage you to look at our website for more information.